Hello, ladies and gentlemen, and welcome to our video on exothermic and endothermic reactions, lesson 13 in our notes. So today we are learning the difference between endothermic and exothermic. We're going to differentiate some graphs, and we're going to talk about where reactants and products fall on those graphs. So before we can do that, we need to talk about the law of conservation of energy, the first law of thermodynamics. Essentially, it says energy can be converted from one form to another, but the total energy has to remain constant. In the world of chemistry, that means in chemical reactions, when we have different atoms, the atoms stay the same, but the bonds between these atoms change, and that's what holds energy. So if we're thinking about a chemical equation like iron and oxygen coming together to make iron oxide, what goes in has to come out. Iron and oxygen are on the reactant side. Iron and oxygen are on the product side. They remain the same, both sides. But what's different is the bonds. On the front side, with iron and oxygen being separate, they're not bonded to each other. But when they bond to each other, okay, that's that bond, that iron oxide, that Fe2O3, that's what holds the energy, is that bond in between those two. Let's discuss what do we mean by endothermic and exothermic. So endothermic means we store or absorbed, endo-absorbed. Okay, so that's kind of how that one works. And we're talking about energy. Exothermic means we release. So I like to think of exothermic as exiting the system, exit out, exothermic. So what that means is this energy can be in any form, but when we're talking about chemical reactions, it's usually typically heat and thermal energy. So when I talk about endo being absorbed, I'm talking about heat being absorbed. When I'm talking about exo being released, I'm talking about thermal energy or heat being released. So endothermic reactions actually feel cold because what's happening is as the reaction is occurring, the energy that is around the system gets absorbed into the system. And so the energy around the system becomes cooler. So the surroundings become cooler to the touch. It's a little colder. Exothermic, when you have the reaction occurring, if you were to touch the beaker or whatever you're using, feels hot. And that's because whatever chemical energy is being released is creating it to warm up because it's being converted into heat. So you can feel it on your hands as if it's warmer. So we're going to talk about the graphs that happen with endo and exothermic reactions. Okay. So they always happen in two main steps. Okay. Um, Bonds in the compounds break apart, which require energy, and new bonds are formed to make products. This absorbs energy. Okay. Whatever step requires more energy will determine if the reaction is endothermic or exothermic. That's the idea. So during a endothermic and exothermic reaction, when it comes to the graphs, we're going to start in our exothermic reaction. So again, chemical reactions always involve two steps. There's no notes on the screen for this. I just said it out loud. So what you need to make sure is you wrote down is step one, bonds in the reactants break apart. Bonds in the reactants break apart. I said compounds, that's true too, but let's go with reactants, which requires energy. New bonds are formed in the products. This energy, new bonds are formed in the products. This activation energy, okay, I don't know what that one's supposed to be. This should just be bonds are formed to make products. Okay, and then whichever step requires more energy will determine if the reaction is endothermic or exothermic. So let's talk about exothermic reactions. Chemicals in exothermic reactions have higher energy than the products. Energy is released to our surroundings, so that's how we form our products. So it looks a little something like this. This is called an activation energy graph. So what you're seeing here is reactants on one side and products on the other. Please add the R's and the P's to your notes. This is really key, especially for Chem 20 moving forward and Chem 30. So what you're seeing here is here's my reactants. This bump right here is just called the activation energy. It's the energy required to get this whole thing rolling. You will learn that as enthalpy later on, delta H, later on in chemistry. Okay, so what's happening here is you're having a reaction and the reaction takes some energy to get started. But once it does, Down here is the products. And the reason the products are down there is because this type of reaction releases energy out into the surroundings, making it warm to touch. So it means that the products actually have less energy in them, but the reaction maintains a steady amount of energy throughout. So if we're looking at the temperature of the surroundings, our start temperature is here, our finished temperature is hotter. And if we look at the total system as a whole, this is the idea of energy is conserved, the first law of thermodynamics. Although we have a change in temperature, the energy doesn't change. We just released it as heat, and now our reaction has a little bit different energy in the products, but products plus the energy released is the same as what the reactants were. So add this into your notes. Oh, you can't see it because I just moved my beautiful mouse right over it. Sorry, guys. So energy is higher in reactants than products because we lose energy in the form of heat. So we lose it to the atmosphere, so products don't have as much energy. Energy in the surrounding areas gets warmer as energy is released through the reaction. So we actually feel like it's hot to touch. All right, so that's exothermic as a whole. Let's talk about endothermic. So, endothermic reactions are when reactants have lower energy than the products. And this is because of absorption. So, here we go. This is our graph now. So, this is the second graph you have. R's and P's, add please. So, reactants are down there. Now, this time, the activation we need to get it started, okay, is absorbed into the system. So we go from reactants to products, and products end up having higher energy bonds because we're absorbing energy from the system, from the surroundings around us. So if we were to feel what is happening, it would almost feel as if the beaker or whatever we're holding that's having the reaction in it gets colder. So the start to finish, it feels colder to touch. But again, we still conserve the same amount of energy. Just because we absorb it in means that reactants, okay, the energy from the reactants to the energy of the products is the same. Okay, it's the same because we're absorbing that energy back into our overall system. So energy is lower in reactants than products because we are absorbing energy in the form of heat to make the products have more energy. But the surroundings become cool because we're absorbing energy into the reaction. So that is endothermic and exothermic. And so we're going to identify and work with these and try to figure out examples of them and how to say if something is exothermic or endothermic based on different statements and whatnot. So if you have any questions, please let me know.